Hey everyone, I'm Arsh. I work as a DevRel engineer at MetalBear, and I'm a CNCF Ambassador too. And this session is going to be about how you can reduce environment chaos, or like the number of Kubernetes clusters your organization has. When I talk about that, I'm talking about clusters specific to development and testing. We are not going to be reducing your production workload, so don't worry about that. But yeah, in general, this is going to be about how to manage the number of Kubernetes clusters you have in your organization, which developers are using, including staging environments. A bit about me, I've been in the platform engineering space for around 4 years now. I used to be an open source engineer contributing to the Kubernetes project before that. And after that, I found out that I like talking about stuff and I like writing stuff, which is when I switched to a developer advocacy role. And now I'm working at MetalBear, where we are building Melody. Cool. So let's start this webinar with a story which might seem familiar to a lot of you. This is the story of going cloud native. So, I'm assuming like uh, you would have started with like a monolithic application or even a microservices based application, which was not running on Kubernetes initially. And you heard about all the benefits Kubernetes has to offer, like scalability and just giving you more control and freedom to take your workloads, manage your workloads better. And with that, you decided to migrate your app to Kubernetes, and that led to your organization having a production cluster, which is all good because at this point, you've just started using Kubernetes, you have one cluster, everything seems under control. Then you realize that pushing directly to production isn't something which is feasible, right? Because things can break and you have no control. So you want to test out your changes in a controlled environment early on. That is when you add a staging cluster. So at this point, you have like maybe two or three clusters. So when I talk about production cluster, we're assuming that you are deploying on a single cluster, but I'm assuming it's not a bunch of clusters, but the number of clusters in your organization are still manageable now. You have a couple of clusters maybe for production and some for staging. Then you realize that it is like as your team expands, staging is not fitting the requirements of everyone on your team. Some people want to test their changes on staging, but they're not able to because some other team is using the staging cluster. And to enable everyone to validate the changes, every developer to validate the changes, you realize that it's time for spinning clusters in the CI so that when developers make a commit, they can run it in CI and test it in CI instead of having to wait for access to staging environments. Now you start to get a bit worried because the number of clusters are getting a bit much, but it's still manageable because you are still seeing the benefits Kubernetes is bringing. Management is happy. DevOps team is like kind of getting a bit anxious and stressed, but it's still manageable. So you have production clusters, staging clusters, and CI clusters, and things are going okay-ish right now. But now, even with CI and staging, developers are feeling bottlenecked because they feel that each team needs its own cluster that mirrors production. They want to be able to test their changes in a realistic environment, and CI just isn't giving them that flexibility to play around. So they need dev clusters for each team to be able to test out the microservice they're working on. And now you have a lot more clusters and things are starting to get out of control, but you're obliged with this demand of your developers. Finally, there are more complaints because starting environments are just not enough. Now, each developer wants their own personal ephemeral cluster, which they can spin up and test things on and then develop against. And once that is done, they may or may not shut it down. And then CI, staging, production, and all of the other steps kick in. Now things have really gotten out of control, and your cloud budget is just exploding. At this point, this starts to become a concern. I don't know which stage everyone identifies to be at right now, but if you could let me know in the chat, are you at this stage? Then you're going to get a lot of value out of this webinar. But are you at the CI stage, staging stage, or just dev cluster stage? Let me know so that we can, see how everyone is doing. But yeah, so when this happens, your cloud bill grows a lot, and that is something which becomes a matter of concern because there are multiple downsides to having like numerous Kubernetes development environments, and it's not just about cost. Like I said, it a lot of clusters also mean like the management overhead on your DevOps team or platform engineering team is much more because already managing production and staging clusters takes efforts. Now, when you expect the platform team to manage multiple replicas of those staging and production clusters, ephemeral environments for developers, and all of that stuff, then that just adds more burden on top of them, which takes time away from other stuff which they could be working on. And even after, taking time away from your DevOps team or spending a lot on cloud clusters, the solution to this problem isn't that great because even if you provide each developer ephemeral environments, ephemeral clusters or namespaces, the provisioning of your app on those clusters, on those on-demand environments would still take time. So developers still wait like 5 to 10 minutes for things to get ready in their ephemeral environment. And keeping these environments in sync with production is just another huge challenge. So these are a couple of frustrations which teams are dealing with when they start to have like multiple environments for development. Now I want to talk about why this is the case, right? Like why this problem is specific to microservices based applications and not monolithical applications which we used to develop earlier. The first reason is that since we split the application from monoliths to microservices, now there are multiple services which are dependent on each other. So if you work on one isolated part of your application, let's suppose you're working on service A, but service A still needs to talk to service B, which might be talking to service C, and so on. So when you want to test out the code changes you have made for service A, you can run some unit tests locally. But if you want to run end-to-end tests or integration tests and see how the entire application behaves, you need to deploy or you need access to all the other services, including databases, queues, and whatnot your application needs. So because of this highly interdependent architecture that microservices based applications have, it's just a struggle to, for developers to create a local dev environment or a remote dev environment. And the second reason why this problem is something specific to, cloud native applications is because production looks very different from what you are able to replicate locally. Because in production, when you use Kubernetes, you have secrets which take which is how you provide configuration. And then you might have other stuff for observability and all of that stuff, which you might have a service mesh. And all of these things are not things that you're able to replicate locally. So while your code might look good, but when you promote it to production or staging, things might break because of a configuration issue which you did not catch, or which you're like your code expecting something and the value being different in staging and something like that. So there is this huge mismatch between what a developer, the environment a developer writes code in versus where it actually gets deployed. So this mismatch is the second reason why, cloud native applications suffer from these kind of problems. So now I want to talk about what the current development workflow looks like in a lot of organizations today. So the way it works is that developers write some code locally, then they run some basic unit tests locally, whatever they're able to run locally. But after that, to get that validation we were talking about, to get that feedback that the change they have written works in the broader context of their application, they have to rely on CI pipelines and deploying to staging environments. And this step takes time, okay? And as developers, we know that your code like most probably will not work in the first time. So when you spend 20-30 minutes going through this process, then you're able to test in the staging environment, and then you find out something is not working. And then you fix that issue locally, you write code for that, and you then repeat this entire loop again. So for each feature or bug fix, you're essentially going through this loop like at least 3 or 4 times. And that's an hour or two wasted per developer per feature. And that time really compounds across your entire team. So each developer ends up spending that amount of time. So if you just calculate it across a team of 100 or 200 developers, that really affects the speed at which your organization is able to ship features and bug fixes. So in this loop, the step which is the bottleneck is waiting for pipelines and deployments, right? Because if there was a way to run and test your application just like you were running unit tests locally, then the loop would be much faster, right? Because you would not have to wait 15, 20 minutes on things to get deployed. Instead, you could just test stuff locally and then be sure that it's working and then just go through the staging deployment process as a final sanity check. So to combat this, a lot of organizations, what they've tried to do is in this phase between when we go to, from running tests locally to build and push to staging, they've tried to adopt some solutions. And we are going to be talking about those solutions next. So some alternatives and where they're falling short. The first alternative, which we also discussed earlier, is like personal remote environments. So basically, organizations are providing developers either ephemeral on-demand clusters or access to namespaces in a cluster and allowing developers to test code there immediately as soon as they write it, and then when they're finally sure, then go through the CI and staging deployment process. The problem with this approach is that in the long run, and especially for bigger teams, this turns out to be really expensive. Even if you're going for multiple ephemeral clusters, which are smaller, then you have just multiple clusters, which is expensive. But even if you're going for one or two clusters and then partitioning by namespace, the clusters you end up provisioning are a lot larger for your entire team, and that is why it just turns out to be really costly. So I have a question which says, where is Mirror-D different from Quarkus? I'll get to that when we come to the Mirror-D part, which we haven't come to yet. So I've noted your question. But yeah, talking about personal remote environments, so the one thing where this is harmful is that just your cloud bill would be a lot higher. And then there is the maintenance overload. When you're managing multiple like clusters or multiple namespaces and replicating your production across these namespaces, then that's a huge management overhead for the DevOps team. And finally, these environments also take time to provision, right? If you're deploying on a namespace or creating a cluster and then deploying to that each time, then that is taking time and developers are just waiting for the environment to get provisioned in that time. The other solution which organizations go with is local tools like Docker Compose, Minikube, Kind, and all of that. Now, while they are not costly at all because you're running things locally, but the setup for them ends up becoming complex because now mostly developers have to debug issues. If there's an issue with Docker or Minikube or Kind, then the developers are themselves the ones who are responsible for debugging this on their local machine, or they end up pinging the platform team, and there's a lot of back and forth. And secondly, which is the biggest issue with all of these solutions, is that they do not replicate production properly. They are a local Kubernetes cluster is still very, I would say, like it is a Kubernetes cluster, but it's still a very different from what your environment looks like in production or staging. So there still tend to be bugs which show up in your staging environment, which you will not be able to replicate locally with these clusters. So those are the two main ways I've seen organizations approach this and try to fix this like slow dev loop. If you are familiar with any other ways which you've seen people use in your organization, you can let me know in the chat and we can, discuss and see what everyone is up to. So now the question becomes is that when you have a lot of these environments, how do you solve the pain points of your developers while getting rid of these multiple environments, while having as few environments as possible? And this is where I want to introduce somewhat controversial topic, at least at first glance when I say the statement, it feels very controversial. But what if you could just use your existing staging environment for development and CI? So a lot of the responses when I say this out loud or suggest this to people at first are that it's just not possible, or what if the shared environment breaks, or people would have to wait for access and all of that stuff. And that is where Mirror-D comes into picture. So Mirady is a local Kubernetes development tool. It is an open source tool which lets you run your local process in the context of a Kubernetes environment. Now, what this means is that your code still runs locally on your machine, but you are able to test it out and see how it behaves as if it was running in the cloud environment. So this gives you all the benefits of, testing on a Kubernetes cluster, testing in a staging environment, but without having to go through the hassles of actually deploying code, without having to wait 15, 20 minutes for CI pipelines to build container images and then deploy those images on a cluster. So you are able to skip all of that and skip that phase, but you're able to still test your code as if it was in your Kubernetes environment, in your staging environment. And as developers, the next question I often get asked is, how is this possible, right? Like, how can you test your code in a production or production-like environment without actually having to deploy the code? So the way Mirady does this is by running your application locally, but mirroring the traffic and data between the cloud environment and your local machine. So Mirady mirrors incoming traffic from the cloud environment to your local machine and outgoing traffic from your locally running process to the cloud environment. And that includes being able to talk to the other microservices in the cluster and copying mirroring the environment variables between the two systems and the file system as well. So let's see this diagram, which should make things clear. So let's suppose you have made some code change for service A on your local machine, and then you run that process for that service A locally on your machine. You're only running service A locally at this point. You're not running service B, any databases or stuff that service requires on your machine. You're just running the service you wrote the code for. And then you have your staging cluster where service A is already deployed, and so are all the other services part of your application, including databases and queues and whatnot. So now Mirady establishes a connection between your locally running process, between your locally running service A in this example, and the service A which is deployed in the cluster. Once this connection has been established, then any traffic which is coming to the cluster and which is supposed to hit your service A will get mirrored to your locally running machine. This way, you are able to see how your code behaves when a request hits that code without having to, actually deploy it. So let's suppose there was some other service in the picture and the traffic actually enters service B in the cluster, and then service B is the one talking to service A. So when service B sends that request to service A, Mirady will mirror that request to your locally running process, and you will be able to see how that request is behaving when it hits your machine. Similarly, when your locally running process needs to talk to other services or needs to, needs database access or access to messages, then it will send an outgoing request, and Mirady will mirror that outgoing request from your locally running process to the cloud environment and make it appear as if it's coming from the service which is in the cluster. So the other services think that the request is coming from service A in the cluster. They reply back to it, whatever response the service A receives in the cluster, that again gets mirrored to your locally running process. And that way, your locally running process has access to all the dependencies it needs to run and allow you to test your code in the broader context of the application without you having to deploy it. So basically, this gives you this gives you access to all the other services your service needs to talk to without you having to set up an environment for yourself. So you don't need to create a cluster and deploy the entire application, and you don't need to create a local cluster using Minikube or something like that, or you don't need ephemeral environments as well, because you can just access all the stuff which is already deployed on the cluster. So to sum up what we have discussed so far, Mirady enables mirroring of incoming traffic between the local machine and the cloud environment. Then it mirrors outgoing traffic between the local machine and the cloud environment. It also allows you to steal traffic for targeted requests. So if a request is hitting your service A and you want to test out the response as well. So right now with Mirady, service A would be the one which would send out the response and not your locally running process. But Mirady comes with a steal mode where when the request hits your service A, then it gets stolen and sent to the locally running process, and the locally running process is the one which is responsible for sending out the response as well. So in that way you can see how the code changes you have made behave in the context of your broader application. So yeah, I see another question. What if my team is developing a Helm chart and wants to test the whole Helm chart, which includes some Kubernetes resources, and deploys a bunch of apps instead of testing only one app? So Mirady is not a tool to test out Helm charts directly. This Mirady is meant for you to test out your application code specifically. So Mirady would mirror like the traffic, like the network traffic and the files system and the environment variables between the local machine and the cloud. But other than that, you cannot like test out your Helm chart as such. But if your Helm chart like is deploying containers and is deploying an application, then you're able to test out the application code which is in those containers. Like if you make changes to that code locally and you deploy your Helm chart, then you're able to see how those locally made changes would behave as if they were in the cluster. But you cannot essentially test out, your Helm chart as such. Yes. So if you want to test out the Helm chart itself, then you need to deploy the Helm chart to the staging environment. But the question becomes then what exactly are you trying to test in the Helm chart, right? So I assume like for most organizations, what you're trying to test out is newly written code, right? So you've built a container image from the code, that code is in the Helm chart, and then you deploy the Helm chart. So if it's code you're trying to test, then you don't have to deploy the Helm chart in the first place. The idea with Mirady is that you already have an existing staging environment where your application is deployed, and now you have made changes to one service in your application or a couple of services. And with Mirady, you can see how those changes would behave as if they were in the cluster without having to deploy them or without having to deploy a Helm chart. So that is the entire point. Yeah, if you want to test out the YAML manifest and go templating in Helm chart, that is not what Mirady is used for. Like Mirady is like the main use case for Mirady is to test out the application code itself and not your Helm chart. I hope that answered your question, but if not, please feel free to ask any follow-up questions. Cool. So the development loop, which we saw earlier, which is like which slows down teams where you write code and you run some basic tests locally and wait on this build and push step. With Mirady, that development loop speeds up immensely because instead of going through the entire loop which saw earlier, like 3 or 4 times, you go through a much shorter loop where you write code, you test it against your staging environment using Mirady locally, and that takes like 5 seconds as compared to 15 or 20 minutes. And then you see that it's not working or something's not working, then you iterate on it by writing code again. And you go through this process as many times as your code writing phase requires. And then when you're done with it, you just do the final step of, like CI and staging testing, which was part of your process too earlier. But the difference here is that now you are relying on this step as a final validation instead of, going through it each time you need feedback. So you're not wasting like 20, 30 minutes per feature, like per code change you want to test. And you are only doing that once you're sure of your changes and just as a sanity check. Uh, yeah, so Melanie asked a question, how do you deal with multiple developers wanting to test their changes to the same service at the same time? I assume only one can intercept the traffic at a time. So Melanie, this is a great question, and this is a problem which we see a lot. And this is where Mirady for Teams, which is our commercial offering, helps. And that comes in the way of a Helm chart, and you install the Mirady operator, which is part of the Helm chart, on your Kubernetes cluster. And then the operator takes care of managing multiple concurrent Mirady sessions. So multiple developers can target the same service, and Mirrord, like the Mirrord operator, will take care of managing multiple sessions and ensuring that there are no conflicts between those sessions, while also at the same time ensuring that the service the multiple developers are targeting that remains functional and the staging cluster remains operational for other people to use who might not even be testing code. So so long story short, the answer to your question is that there is an operator which takes care of managing multiple concurrent Mirrord sessions. I don't have a slide to get into that, but I have details where you can reach out to me if you want to learn more about how that works after the webinar. So to sum up, basically, with before Mirrord, the way development works is that you either need personal dev environments, which are expensive, or you end up spending time waiting for CI/CD, which in turn costs you in terms of time. Or there are issues like someone broke the staging environment or something happened and it's unusable. Whereas with Mirrord, you can just use your existing staging environment to test out your changes, allowing multiple developers to test out their changes against the same shared staging environment concurrently, while being able to avoid the tedious steps of waiting 15-20 minutes for CI pipelines or staging deployments. So this allows you to shrink your cloud bills, save a lot on dev time, and just allows your developers to be happier and more productive when they're writing code instead of dealing with the frustrations of waiting on pipelines and deployments. So that was the end of my webinar. If you want to learn more about Mirrord, you can go to metalbear.com/Mirrord, or you can check out the project on GitHub at this link. If you have any questions, you can reach out to me on LinkedIn or Sharma, or you can send me a mail. Now I think we can open for Q&A, and we can stay as long as people want and answer questions. So I see one other question. Thank you for the answer. That means if dev teams are developing the Helm charts for their own services, then each dev team would need separate namespaces in staging or separate dev environments where each team can test their own Helm charts. And we again get the problem of each team wanting their own environment. So yes, if your dev team is like, I don't know, I'm not able to get the context of how development works entirely in your organization, but from your message, I'm getting the idea that dev teams are responsible for like providing the DevOps or the platform team the final Helm chart for the entire application. And that is why you are saying that developers need to test out the Helm charts as well. But can you confirm if I understood it right? But okay, yeah. So what I what I'm what I'm understanding is that like once the Helm chart for a particular application has been created by a team, it has been deployed on a cluster. When a team has to iterate on that, what I'm assuming is that essentially what's changed is the application code, right? Like not a lot of changes would be made to the actual Helm chart itself. It's just that the code which has been changed. So if code is the only thing that has been changed, then developers can test that code out using Mirrord, targeting that environment where they have the previous version of the Helm chart already deployed. And they are able to test out how this code would behave. And once they are sure about the code, then they can just update the container image in the Helm chart and just be sure that the Helm chart would work when promoted. If the Helm chart itself changes drastically, then yes, with Mirrord, there is no way to test out the Helm chart. Like the Helm chart changes itself. If just the container image has changed, then you can test out that the code there. But you like I said, there's no way to test out the Helm chart itself. But what I don't understand is like I'm assuming that not a lot of structural changes to the Helm chart which are common, and instead it's mostly just updating the container image, which is part of the Helm chart, and deploying your application. So if that's the case, then Mirrord is useful there. Let me know if you have if that answered your question or if you have more questions. So another question I see is, yes, Mirrord does save time. Do you see customers that are using to test it in production in the same way you described to No, we do not. We haven't seen, at least in my best of my knowledge, we haven't seen customers use it in production, even though I would argue that you can possibly do that. Like Mirady takes care of making sure that your environment does not break down for anyone. So nobody's actually deploying code to that environment, right? It's just mirroring of traffic, which Mirady very intelligently takes care of. So that's not a use case we have seen because people are usually very scared of touching their production environment. But you can do that theoretically with Mirady. That should not be a problem because your production cluster will not break down even if you're testing against it. But then again, like I said, people are just scared to do that, and like I would be scared to do that as well. But that's possible. But this reminds me of another interesting use case which we are like seeing more customers do these days, is that with their staging environment, they'll target a service and then like send the staging environment to non-engineering persons, let's say like a product manager or someone who does not write code. And then that person is able to see how a deployed feature would behave. Because when that person, hits that endpoint of the staging environment with, so Mirady allows you to set headers so that, identify which request should go to your particular session. So if someone sends a request to the staging endpoint with a fixed header, that request would get routed to a particular developer's machine, and the changes they have made locally would be visible to the person sending that request. So this way, product managers, product designers are able to, see how the changes the developers working on would behave without the developers having to, create container images and deploy them on staging environments. So basically preview environments. So that's a use case which we are seeing uh, which we are seeing customers use, and we are, going to support that more formally in the coming few releases. I hope that answered your question, Alexi. What sure are the cons of using Melody compared to personal environments? Compared to personal environments, I can't think of any cons because like the experience is the same as if it was your own environment, but the pros are that you don't have to wait for the environment to get spun up, so that saves you time. But and you don't have to manage multiple environments. So there are really actually no cons to using Melody compared to personal environments. What are the pros of using Melody over something like Quarkus, and when would it make sense to decide for Melody over Quarkus? So I would love to answer this, but the thing is, I do not know what Quarkus is. So I'm going to do like a quick search and see if I can figure out what Quarkus does in like a minute or two and answer your question. But please feel free to send me an email or like drop your LinkedIn, and I can reach out to you and answer your question.
Thank you, Arsh. And Albion, I hope I'm pronouncing correctly your name, but don't worry, I will share with you Arsh his email, and then you can just exchange emails there. But yeah, I don't know if you guys have any other questions because we are running out of time. Let's see, let's give it a minute. All right, I see no questions. Okay, well, thank you so much, everyone, for joining us. Thanks, Arsh, for the amazing presentation. Very much appreciated. And yeah, remember, guys, if you come up with more questions later on, share it with us in the Slack. I shared it in the chat. And yeah, I hope to see you all soon in our next webinar. Thank you.
Thank you for having me, and I hope this was useful. I love to hang around the platform engineering community and hopefully be a part of more webinars and see you all more.
Thank you so much. All right. Well,